welcome everybody. It's my pleasure to introduce today's speaker, Professor Marshini Chetty from the University of Maryland. She's in the iSchool at Maryland and also affiliated with the Computer Science Department and the Cybersecurity Center and some other acronym things. She received her bachelor's and master's degree from the University of Cape Town and her PhD from Georgia Tech, working with Becky Grinter. And she's going to talk to us about helping consumers deal with internet data.
Great, thanks. Okay, so thanks. So today I'm going to tell you a bit more about how we designed a tool to help people manage internet data. And I'd like to start off by showing you a video. Oh, we don't have sound. Oh, uh-oh.
I'm your father.
I'm sorry. I've been capped, and I can't show you the rest of the video. Hopefully you know that Luke is, in fact, Darth Vader's son. But yes, although this is simple, this actually happens to some people. So let's talk about what is a data cap. So a data cap is actually a limit on how much you can download, or in some cases, upload per month. It really is hampering or changing people's usage, because you might be doing something like watching a video, sending an important email, and you could just be cut off like that. So it really changes our style from this all-you-can-eat, just browse, do whatever you want. And data caps can really be different. They range from very low caps, as low as 2 gigabytes per month, to higher caps, like 250 gigabytes per month. So how many people here have a smartphone? Everyone, I assume. How many people have the unlimited plan? Okay, so everyone here is obviously early adopters, unlike me. So on my smartphone, I have a 2 gigabyte limit, and that's basically just for me for the month. So data caps for home broadband plans can be as low as 2 gigabytes per month for a whole household, just to give you a comparison of how little that actually is. And even when there's unlimited plans, they're not limited. So if you think about your unlimited mobile plans, I know someone who's on a mobile plan on AT&T, and he recently received a message saying that he had used more than 3 gigabytes per month, and if he continues to do so, they're going to shape and slow down his connection. And this is the same with home internet plans. So once you reach the cap, there can be several consequences. You can get cut off from the internet, you can be severely shaped, or you can get charged a hell of a lot of money. Now, caps actually exist everywhere in countries all around the world, and also here in the States. So recently, Comcast, one of the major internet service providers here, said that they were going to introduce data caps on everyone. So they announced this year, and there was a huge backlash from the public saying, this is a terrible thing. In fact, they already have data caps. It's just that they don't enforce them. Well, that's not quite true. They enforce them in certain states at the moment. So given that we have data caps, and it's changing how people are using the internet, what are people researching in this area? So it turns out not that much. Some of the related work is actually done by a team here at Princeton in the ECE department. So Professor Meng Chiang and a postdoc, Samir Sen, did some work on smart data pricing. So they did an experiment where they wanted to see if people time shift what they're doing based on how data is priced. In another related study at Google, they developed a smart browser where they did another experiment, forced people to use the browser, and in the browser they could search for a particular set of results, and before they actually click through on a link, they could see the cost of accessing that page. So again, very much focused on showing people what the cost of mobile data is. So the work I'm going to talk about today differs from this study because we're not just focused on cost. We were trying to understand how do data caps actually affect how people use the internet in the home, and what sort of tools might they need to manage data regardless of the cost of the data. So in order to understand the kinds of stuff that I'm going to talk about today, I thought it might be helpful to tell you a little bit more about my general approach. So it's very much similar to a systems approach. I start off with formative work where I try to understand users, move on to design of interfaces, sometimes user experiences, and then implement usually a prototype or sometimes a fully functional system to get people to react to it. And then I use that to actually evaluate or observe and either refute or confirm my initial hypothesis about the system. So to understand this problem of data caps, we wanted to do some formative work. So I started thinking about this in about 2011 when data caps hadn't really come into the States. And I think AT&T and Comcast introduced them shortly thereafterwards. But how households actually deal with data caps, we found a really good environment to study this in, and that was South Africa, because the data caps there are very low. They can start from 1 gigabyte per month for. And at the time of the study, or at least just when we started, everyone in South Africa was on a cap data plan. Okay? Shortly afterwards, they introduced this concept of unlimited plans, but even so, unlimited plans had limitations. They have a fair usage policy. Again, if you reach a certain amount of data, you basically get heavily shaped and they're very slow. So I asked two questions. How do households currently deal with internet data? And how do they actually manage this? What sort of tools are they using? What sort of tools might they need to actually manage data in the home? I'm not going to go into too much detail about this, but just tell you about the findings that relate to the tool I'm going to talk about today. So we did formative work in South Africa in a variety of households. This was one of the low-income households that we visited. And we studied their data usage practices under data caps. Most of the households had connections, but a couple of the households in our study actually had uncapped connections so that we could compare usage amongst the two. There's a paper on this if you want to find out more details, but I'm just going to tell you about the things that we found that people were struggling with data usage in the home. The first thing was people, so they had a data cap, say they had a data cap of 10 gigabytes per month. They were struggling with this idea of an invisible balance. Usually the provider only provided minimal information about how far they were on that balance at any time in the month. So we had people saying things like, you know, it's only the second week of the month and I've already run out of data, but there's no way for me to track this. Say things like, well, the provider did send me an email, but I only got that email after my internet connection got cut off. I went and restored it, and then I received the email. So often it didn't come in time. And the process of actually restoring your connectivity, ironically, often depended on you being online, or phoning a provider, or actually going to a provider to actually get back online. So people were really wanting more information in real time on how much data they were using through the month. The second thing that was very confusing to people was what was using up data. So you probably have a good idea of what kind of applications use up data, but for the average person, it wasn't easy to tell, you know, which device is using up data. Is it Facebook? Is it YouTube? Is it my email? Is it something I can't see? All of the households that we interviewed and spoke to during the study had multiple users. So this was another source of confusion. Most of the households said that they suspected it was either a teenage son or, you know, some people said, oh, it's my mom. She's always doing X, Y, and Z on up the connection, but they couldn't really prove it. They couldn't really say for sure who was using up the data. And this led to a lot of frustration because people wanted to make sure that everyone had enough data to do the things they needed to do. The final thing that came out of this formative work was that people didn't have a lot of control. So they said, okay, not only do we not know what and who is using up data, but we don't have any way to control this. If I had a data cap, how would I share that among the people in the home? So using sort of standard HDI techniques, we created a bunch of design ideas, which we then took to the same households to get feedback on some potential interfaces and systems that we could create. So we went back and said, well, what if you could show where you were in terms of your balance for the month? And what if we could show you a projection of where you might run out if you continue your usage as you're doing now? We also said in terms of processes and things using up data, what if you could see whether it was Facebook or YouTube or Wikipedia that was using up a lot of data? And then with multiple users, we said, what if you could actually allocate data to different users or see how people are doing, how using data or your data pie? So with the controls, you know, we wanted to see if people would do things like, I have 10 gigabytes per month, and Ryan and Mike and Andrew, and I get 9, and you know, they share the rest of the 1 between them. So a lot of feedback on this from these households, and they really liked all of the information that and ideas that we had. These are just some of the designs. they didn't really like the idea of singling out a particular person in the household for obvious reasons. So we took this formative work, and then we started thinking more about, okay, if we are going to create a system to help people manage internet data, how would we do this? If we were going to provide people with visibility over the data caps, could we do something like expose the websites or devices that are using a lot of data and when they're doing so? And how would we give people this control over data? Would we be able to allow a user, for example, to control the data a user or device or website was actually sending? So we started thinking about this and how to create the system. And we encountered a lot of challenges. So the first is, because of previous work that I'd done, so this was a collaboration. In my previous work, I sort of did the system end to end. In this particular case, I collaborated with some systems researchers, and we were using routers to gather a lot of data. Now, the problem with the router, which is where all the devices connect to, and the internet in your home, if you don't know much about it, is it has limited memory and storage, which means that if you want to do a lot of processing, you can't really store it or do it on the router. The other thing is, in terms of a router, if we wanted to put special firmware on the router, we wanted to make the system easy to use and configure. So we envisioned sort of giving these routers to use the system, and we didn't want people to have to flash a router in order to use our system. And then we wanted to have a system that was very responsive, so that they were getting messages about data usage too late. So we wanted to make sure that they got real-time information in actual real time. And then from the HCI side of things, okay, we wanted to do this in a home, right? So if you think about and multiple users, there's some notions of privacy that we have to be concerned about when we're thinking about tracking what people are doing, even if it's just data usage. Also, just like everyone in this room, we're all busy people. We didn't want to create a system that would add more burden to people's lives, where they would have to control little details in a already busy schedule. And then thinking about tracking usage, we wanted to be cognizant of the fact that usage patterns change, and people have different technical abilities. So it's not always the case that you can just create one system that fits all the users in the house. In terms of the actual tracking itself, so a lot of the processes that send and receive data are invisible. Okay, it might be that you have a background process running that's actually contributing to your CAP, but you may not be able to see that. So we wanted to think about that. And then we also wanted to think about, okay, we track a user sending data in the house versus a device sending data versus a website sending data. And again, privacy was really at the forefront of our minds here. Given that we wanted to track people's device usage or data usage, we had to think about how to build this in the system. Once we had grappled with these challenges, we came up with some requirements. So the basic requirements for our system, which we called uCap, as in you set the caps, were to have visibility, so to be able to track users, devices, and websites' data usage and show that to people in real time, to actually provide a history of that over time because of the changing usage patterns, and then to give people this control. So when we first started out, we thought maybe we could allow people to set a cap on a particular user. Reasons we moved away from that, which I'll describe now. But in terms of that, that would basically be like me saying, again, if I was living with Brian and Mike and Andrew, I have 10 gigabytes, and then I would set a cap on each of their machines so that they could not exceed that 1 gigabyte collectively. So we did what all computer scientists do, and we hacked together a system to see if it will work. So this is our first prototype, which we demoed at the SIGCOMM conference in 2011. It was very basic. It showed basically all the list of devices connected, and it could show the data usage in real time. It was very responsive, so if you played a YouTube video, you'd suddenly see the data usage on that device going up. It just had kind of a bar chart so that users could see when a device cap was reached. So the system also allowed you to set a cap on a device, it tracked it, and then if the device reached the cap, we just took the same approach as the ISPs in South Africa and cut that device off from the internet. So the system worked really well, and then we started thinking about, well, how could we actually make this look a lot better? And we started to think about the interface. So we started off again, we do this a lot in HCI with designs, And we got feedback on these designs from experts in our group. So these are different ways that we thought the information could be presented. One thing I wanted to point out here is initially we thought if we live in a household together, maybe I could say, well, I, Marshini, have an iPhone, an iPad, a laptop, and all these host of devices. What if I could show Marshini like the data usage for everything that she's doing? And from feedback and the feedback we've received from formative work, this was not a good direction for us to go. If you think about how you get online in the home, you just sort of use a machine, you might use a shared machine, and in order to track users' data usage, particularly on shared machines, we would have to give people a login. And we just figured that that would break how people use the internet at home. Move away from that and only to track device usage. Because in most cases, as some of our shown, a device is associated with a person, and that information can be inferred. So this is the final architecture of the system that we came up with. So basically, all the devices connected to the home router, whether it's an iPhone or a computer, laptop, etc., gaming, Xbox, are all tracked by the router. So in this case, we use Bismarck. This took place while I was at Georgia Tech, so Bismarck is developed by our collaborators there. Bismarck tracks all the data usage statistics and pushes it to the cloud, where we have our network controller. And this basically is through a secure connection. If the network sees that a cap has been and that the cap is being reached, it can then insert an entry into the router in the person's house to actually cut that device off. All of these usage statistics are also pushed through to the uCap interface, which also sits in the cloud. And then the user can view and manage from the uCap interface. So this was to address the challenge of having the limited storage and processing power on the router.
Do these, the dotted lines that cross the home network boundary, they actually participate in the bandwidth that,
yes.
And so by inserting these extra communications, actually increasing the
yes, we're actually the cap.
Yeah.
So we are very aware of that, and actually we made a decision not to make it that visible because it was quite minimal. So we worked it out that the distribution of the uCap system itself, but that is something that through our study we found that people wondered how much the device was actually using itself. Does that sort of tell you? Okay. Yeah, so this is the final architecture which we created to basically address these issues and to make this a very easy system to deploy. Because all of this stuff was in the cloud, stored in Georgia Tech servers, we could really just equip the boxes with our special firmware and mail them out to people, get them to just enable, either plug that in behind their existing router or replace their existing router and enable the uCap in order to participate in the study.
Was there a special rule that if their connection was cut off, you could still access the uCap?
Yes, I forgot to mention that. So to prevent us from actually messing with people's internet connection, if any connection between the controller and the router was broken, we would just drop everything and just not enforce anything. So even if you couldn't get to uCap, you would still be able to use everything as you would. And that's, when you're doing these kind of internet experiments in people's homes, you have to be careful and think about things like that because you don't want to affect people's connectivity.
Just so I understand.
Yeah.
The cap that you were enforcing there was your own experimental cap, not one that the broadband provider was enforcing on them?
Yes. So basically our way to say, giving you a tool to share out bandwidth in your house, and we will enforce these caps within your own house, because that's what we were hearing from the formative work. So we also had to think about how to build in privacy, not just to protect our users, but also to help us recruit people. So we had to come up with our institutional review board. I'm not sure how many of you have experience with Princeton's. So we had to come up with a very complex privacy policy because we were actually collecting measurements of how much data people were using. We came up with this privacy policy not just for the IRB, but also to make it available to anyone participating in the study. We also did create the system where we could not only device data usage, but we could also track a set of websites and their data usage. Now that sounds very scary, but we limited it to the Alexa top 100 sites. So Alexa sort of shows the most popular websites in a lot of different regions. We limited it to the top 100 sites in the US. We removed all pornographic sites or sites that we felt were sensitive. And we also provided this as a whitelist to people, which they could edit. So they could actually add and remove sites to it in advance of the study. We also hashed all the MAC addresses. So we hashed the MAC addresses so that researchers would never know the MAC addresses of the person's devices in their home. And then for the first cut of the study, we decided to focus mainly on technical users. Because the system was still complex enough to, no, I couldn't think of any other way to represent technical. So, we decided that we would stick with technical users because they'd be able to, comfortably get a router, plug it in behind the, identify which was the other thing they had to plug it in behind, or replace their router. And we wanted to focus on these motivated people who were interested in data caps first before moving to the rest of the population. So this is the final uCap system. It took us about a year to build it. So we started in July 2011, and we finished building it later. So people could log onto the website, and then they would see various things which correspond to those findings from the formative work. So to give people information about their balances, the first thing that they landed on was a page where they could see their household usage. We allowed them to actually tell us what their bandwidth cap was, if it was 250 gigs or whatever, and we would track how much data was being used in real time by their household and color in the bar accordingly. So if they were reaching their cap, the bar would be close to red. If not, it would be blue. Here, we did not cut people off if we thought they reached their cap, because there was no way for us to know if our counting was the same as the ISP, and we did not want to cut off anyone from the internet. The other thing that people saw as soon as they logged in was a list of their devices. So here you can see a whole listed. The MAC addresses are sort of hashed. So this did actually cause some problems. People had a hard time identifying different devices. But it shows people kind of, as soon as they log in, who is on the network. And they can actually see a break of who's using up a lot of the data to that point in real time. So here, my laptop, basically on a wide and would show up as two different things because they have two MAC addresses, was using up most of the data. People can also drill down in uCap, so they can look at a specific device and see that real-time information for a specific device. So if they want to up and say, why is she using up all this data? They could see how much data I've used. They could also set an email to say, notify me when I'm reaching close to my quota. Again, because people's patterns change over time, we allow information historically. So they could select any period of time, and we'd display the device data usage for all the different devices that we had seen on the network over time. This is what people would see in terms of the website data usage. We decided to only show them the top 10 bandwidth data consuming websites, because we figured that those would probably be the ones that they would be most interested in if they wanted to change their usage. In terms of controlling their data cap, people could go actually set what cap was, but like I said, that didn't actually enforce anything. And they could also go for each device and either choose to set a cap, disable, or enable a cap for any device in the household. So we had great ambitions to test the system really extensively. And we started recruiting people, and over 100 people signed up. But because of IRB, where we had to get consent from every single person in the household who was going to participate in the study, a lot of people dropped off. And the other thing was because we were mailing out routers, that created some difficulties, which led to a smaller sample size. So we got 21 users to use uCap, and they used uCap from 2012 to March of 2014. Some of our users are still using uCap. 13 of these were in the States, 6 in South Africa. This was intentional. So we tried to recruit people in different countries because we wanted to see how and when they have different data cap policies, and the ISPs enforce them in different ways. Of this study, we sort of analyzed the network managements, and then I performed an in-depth qualitative study of 10 of these households. So that involved interviewing people and having them complete pre- and post-study surveys about their general internet experiences, their general interest in tracking the data cap, as well as how they used uCap over time. I also logged what they did with the uCap system and collected their network measurements over the same period. The usage among these 10 households who participated in the in-depth study varied from 1 month to over a year. And like I said, some of these users are still using uCap. All of the interviews were audio taped, transcribed, and coded theory, and the logs and measurements were analyzed as well. And so what I'll discuss with you today are basically the themes that came out of interviews.
Quick question.
Sure.
Can you say something about what they knew about your study before, before they started using it?
You're talking about the 21 or the
Either
21?
one or both. Yeah.
Okay.
I mean, so did they know
So-
what you were trying to do when they were? using
Yes,
it?
so we specifically recruited for people who are interested in monitoring a cap. So we created a promotional website. We did a recruiting push on social media, so Facebook, Twitter, etc. We also blasted out to mailing lists,
But they weren't
contact
people you knew
networks.
in advance,
They were not people in advance. Yeah, so all of the people that signed up were people who had some interest in monitoring data usage on their networks. So the participants in just the 10 households who did the in-depth, there were a variety of different income levels. Did you have a question?
That's probably the answer.
Oh, okay. The majority of them actually had caps, and 4 were uncapped. The caps ranged from as low as 40 gigs to 300 gigs per month. The cost, as they reported it, so their cost per month of internet connectivity was between 32 and 110. And the technical backgrounds, I mean, we specifically were recruiting for people who were able to actually plug it in. We achieved our goal, so we got very technical people. And we primarily interacted with males when and so on. So in terms of uCap usage, the interface, we had very crude measures. It turns out that instrumenting an interface to log what it's doing, it's very hard to predict exactly what you want to get out of those logs. And so the measures actually, many just told us how many times they accessed the interface. So we know that each of the households accessed the interface between 4 and 115 times. They all found the system really easy to use in terms of just plugging in the router. And I'm going to show you a very confusing graph, but I don't want you to get much out of it. This is a graph of usage of accessing the interface over just part of the study. Each of these lines represents a router, and this is out of the 21 routers. And those red crosses basically represent a time when we know for sure that they access the interface. So the main thing I want you to notice is that some people access the interface a lot. Some people access it much less frequently.
Okay, quick question. If they ran out of their cap, you said you didn't do anything, or
Yes.
so did they know? I mean, if it's actually not using to affect their thing, could that affect how they do the way they access the interface?
You mean like if they got cut off and then?
Well, let's say they never access the interface. If they were actually afraid of getting cut off, it might slightly change their behavior of accessing the interface.
Did they know they weren't going to get cut off?
Yes, yeah, we told them that before, that our system would not
They
enforce
were
it.
mainly using it just to be curious to discover what they're doing as opposed to.
Yes,
Okay.
yeah. Did you have another question?
Were these mostly power users? I mean, people that use the internet for very specialized things, like heavy BitTorrent sharers or stuff like that, or
Not
just normal
really,
people?
not really. When I say technical, I mean some people had a technical background, and some people, I mean, they had interest in their networks, basically. So these people who, I guess that some of them were power users. Some of them were the type of people who would go actually build something to help them track data usage in their house. But some of them were not. So some of them, one, for example, household was a grad student with a family. She did have a technical background, but she didn't show much interest in monitoring her network. She was just curious about data usage. So these are the main study themes. So when we code the data, we basically look through the interview transcripts, look for themes that emerge from across the transcripts, kind of group those themes, and these are what we discuss. And we use the quotes to substantiate our findings, and those are representative of the main themes that we saw cutting across the data. So these are the themes that I'm about to discuss. The first is kind of going on what Mike was saying. Why did people want to use this place? So they basically wanted to track their data usage. In some cases, people with a cap wanted to make sure they weren't going to hit the cap. In other cases, people wanted to make sure that there was nothing funny going on in the network. Curious about how much data different servers For example, one person said, I want to know, whether Hulu or Netflix or HBO uses up more data. So a lot of times they were just curious about usage. Before uCap, what we also heard from most of the participants was this lack of understanding of how ISPs track data usage. So here's one household who said, I don't feel like I have a lot of control. All they say, they being the ISP, is a net number, and I don't have a lot of control over that. So we heard this again and again. One other household told us how the ISP, this was an ISP in South Africa, actually rated people depending on how much data they used. So if they were on a higher rating, their connection would get shaped more heavily. And if they were on a lower rating because they didn't use that much data, they would get a faster connection. Unfortunately, this was all non-transparent. There was no way for them to tell why they had gotten onto a higher rating or not. They would just get the rating. So we heard that this was a real issue. People didn't have any way, aside from relying on the ISP telling them what they used, to actually prove that they had done something different. In terms of tracking the overall usage, so people were able to use uCap to learn the overall household usage and see patterns of use over time. So the first was just to see how much they were using. We had this one enthusiastic household where the guy was like, well, I was so surprised. I was like, check it out, guys. I'm using over a terabyte a month. This is a very unusual guy who was doing all his backups to the cloud, apparently lots and lots and lots of backups. But he was able to see and confirm that, yes, he in fact did use a ton of data. In another case, we had a household of 5 young males who were doing a lot of streaming media. So they were roommates or grad students, and they found out that Comcast was going to start enforcing the cap in the region that they lived in. And they started monitoring and said, we've been monitoring our usage pretty closely on uCap ever since then, because they wanted to make sure that their usage was actually the same as what Comcast was telling them, because now the threat of actually being charged was very, very real. People also use this to track device usage. So we showed them the overall household usage, but we also showed them the breakdown by MAC addresses. So they used it to kind of start a conversation with other people in the house. This was, again, this was the household with roommates. They said, well, uCap breaks it down by MAC address, so I can actually go to the roommate and say, hey, Brian, why are you using up so much data? Is it because of that course you're taking or teaching? And because of that, they can actually use that to help curb or change usage. This roommate actually said it wasn't so much to point out, okay, Brian, you need to stop using the internet, but is it that you let BitTorrent running, or is it something that you're actually aware of? They wanted to make sure that no one was using data unnecessarily. They were also able to detect unusual activity on the network because of the visibility that uCap provided. So another household said, this is an example that we noted, that they found out that one of the laptops in the house was infected with a virus, and that was because the usage was really high. Okay, so making the information visible can also point out unusual activity in the house. And then the final thing was people started becoming aware of the uses. So one of the households, to kind of represent this theme, was saying how he found it really scary that his phone, when he was sleeping, was doing all this stuff in the background, right? Because you're just not aware that data is being sent even without you being, you interacting directly with the device. In terms of the online activities, this was a little bit more confusing to people. So remember, this is kind of what we showed people. And we heard from a lot of people that this didn't give them the information they wanted. So one of our households said, whenever I watch Netflix, for example, it doesn't show up as coming from Netflix. That's because we were tracking the domains. We only tracked high-level domains, and we didn't sort of group domains together into a stream. So a lot of content, for example, is hosted on content distribution networks like Akamai or Amazon Web Services. So in our system, it would show up as Amazon Web Services or Akamai, and to most people, they didn't understand why it wasn't showing up as Netflix. So this is definitely something we could. One of the interesting things that we found is, so we gave people this ability to set caps, right? And we thought, when we were first presenting this work, actually a lot of people were like, oh, that doesn't seem like a good idea at all. But we gave them this ability, and we see whether it would cause anarchy in the home or what people would do with it. And it turns out it didn't actually cause that much disruption. People just sort of controlled or self-mediated behavior. So one of the households, it was a couple, and he was saying, you know, my partner watched a lot of, and I thought that this was going to put us over the edge. But when I saw it didn't, I just kept quiet about it, basically. So in other cases, people said, well, they actually did go and speak to that person and tell them to curb their usage. In terms of numbers, only 4 out of the 10 actually used the capping functions. And all of the households told us that they didn't feel that the capping in the system was necessary, but they were able to use uCap to actually still do control and change their usage over time. Probably the most surprising thing that came out of this was around privacy. So we thought, and we had taken all this effort to build in privacy-preserving measures, hashing the MAC addresses, not tracking everything. And you know, people were really happy about this. They said things like, well, if the ISP has the access to the data that the researchers have, what are they going to do with it? You know, what is the control that I will have? What are they going to use it for? People worried about things like the ISP tracking illicit activities, you know, their downloads. About things like the ISPs selling the data and making money off of it, right? And at the same time, everyone was saying they wanted more detail in the uCap interface. So they did want to know if it was Netflix using up more data than Hulu or HBO. And they did want us to show the MAC addresses and more information about devices so that they can more identify them. So we saw a lot of tensions between what people actually know about what ISPs can already track, what they would like to know, and how they feel with sharing this data. So what are the major kind of takeaways that we got? I think for me, one of the major takeaways is that uCap does actually help people understand more about data usage in the home. So it tells people more about household, device, and user data usage, even though we don't point out users directly, because in most cases, a device is associated with the user. And that this is something that's come up again and again in our research, or in my research on networking and creating network awareness systems. The home network is pretty much a complex socio-technical system. It's a very hard environment to design for because of all the privacy issues. But for us, we thought uCap was still successful in helping people control their behavior because they relied on social mechanisms to do so. We were able to use uCap as a basis for conversations. And for us, that was still a success in terms of helping people to control their usage. The other thing that was interesting to us was that privacy in the home is really complicated. Although you want to provide people with this information, they have sort of conflicting ideas about whether they want to share the information, but they do want more responsive and more informative systems. And then for us, this just reinforced our formative work and understanding that caps do affect internet usage and design. But what are some implications? I think the first is, just like Comcast tried to introduce data caps now, a lot of you said you had unlimited caps. I do not. Data caps are not really going anywhere. We also have an increased reliance on the cloud. There's the Internet of Things. This is generating more background traffic, which means that this is an issue that's going to and designing for the home, but even if you're designing for the home or on mobile, I think that people need these kinds of tools that make information more visible to them if they're going to understand and be able to hold ISPs, for example, accountable for what they're doing. In terms of improving the system, we have some ideas about one way to mitigate privacy concerns would be to actually improve storage and processing power on the router, store the data in-house. You could actually, there's a whole area of trying to do real-time classification on network streams so that you could actually say to someone, all of these flows belong to a Netflix video, so that you could actually give people that information. And we'd like to obviously incorporate cost information, which I said at the beginning is something we didn't think about when we were starting off with this. I just wanted to end off by saying, this is not all I do. So I see how people use the internet, and I create tools to help them manage different aspects of internet usage. I've basically been talking about data management currently, I'm focused on mobile data management. So I've been studying a project on how people use mobile data, and we're working on creating a tool that can help developers understand how their app performs under different network conditions. I've also done work on network performance and creating systems that tell people more about the speeds that they're receiving. I'm working a lot in usable security. Happy to tell you about the projects there. And a lot of my work occurs in places with resource constraints. So I'm from South Africa, a developing country, and so I find that there's a lot of interesting problems when the internet's very constrained. So a lot of my work takes place in those areas. And then finally, because I often provide a lot of empirical evidence of what people are doing on the internet, my work often has some ties in or influence on technology policy. So some of the studies I've done, for example, in South Africa have influenced broadband policy in that country. These are all the Army grads, PhD students, master students, postdocs, and faculty members who helped create the uCap system. And this was the funding for the project.
Excuse me, you can have a programmable router and just put all the functionality in the router of the person using the system. So why didn't you put everything at the home of the user?
We could have. So I mean, in some sense, we did have a programmable router, or router, as I say, because we were using, so our network controller was just not located with the router. And the main issue with the router is you would need extra storage power, like extra storage and extra processing power. So for example, in a previous system I built a system called Kermit, which was showing people the speeds that they were receiving. And I did that totally in-house. So what I did was I connected a laptop to a router. Data could be stored in-house, and the processing could be done on the laptop. For this system, we just decided it would be easier if we didn't have that extra step, and we didn't have to put a router into people's homes, to go the other route and actually put it all in the cloud.
But then you have all the privacy issues.
Then we have all the privacy issues, true. But we also have a system that's easier to deploy. So there's trade-offs.
That some of your measurements and characterizations in South Africa had influenced policy there. Can you talk about like a specific example?
Sure. So we did a study that was basically of measuring. We did a small-scale study to measure broadband performance. So we measured the same Bismarck routers to deploy in all the provinces of South Africa. And we had like a small set of users, basically, I think about 17 routers. I need to go check the numbers. And then we also used a mobile speed test app to get people to sign up and download the speed test app. And then we partnered with a kind of the most popular web forum in South Africa. They had a speedtest.net server, and they provided us with speedtest.net measurements for the same period of the study. We used all of that to basically characterize performance there. And we found things like mobile performance is actually way faster and more responsive in South Africa than the wired connections. And that stuff was used directly as input to, we're still forming a broadband policy in South Africa there. And the NGO director was the person who was sort of directly interfacing with government on the broadband policies. So that's kind of how we helped sort of push our results. We also made the results available as a policy brief so that we'd reach.
Data to slow down mobile? Or?
No. I mean, the reason that mobile is faster there is because first of all, everyone has a connection there. We don't have cable or fiber. Well, it's slowly getting, we're slowly getting fiber. The other thing is mobile is faster there, and it's more popular because there's not a lot of startup costs, right? You don't need to get a wired phone line or anything like that. So a lot of people are on mobile. And the one thing we did find was, although it's faster, it's still not as reliable. The connectivity is up and down, right? So if you did want to watch your Star Wars video and find out about Luke and Darth Vader, you probably wouldn't want to have a mobile connection. You still want to have a wired connection. But that's one example of stuff I've done. Further back in the past, I did some work studying how to use voice over IP in South Africa and how that could be used for systems for rural areas. And that was when voice over IP was actually banned in South Africa. And again, that was picked up by the media and also used as a case to kind of help change policy and make it legal. So most of the time, I'm not the policy person. I try to use my work and interface with policy people who can then use the results to help influence policy.
How scalable is your uCap system? I mean, could you go to all the households?
It's, at the moment, what people would need would be to flash their routers with our firmware in terms of reaching a larger amount of households. So from that point of view, yes, it is scalable with some limitations because most people are not capable of doing that. I think if we had a system that was really easy to push, or if people gave us permission, which we can actually flash your router for you, then we could actually put uCap in all of your households if you really wanted.
There's
But
a lot of default passwords all over.
yeah, but I don't think that that's not something we can do now. And that's that's another reason why. So I mentioned that my initial system was putting everything in house. That's another reason why we moved to the cloud, because I felt like that was a more scalable solution. But there's still limitations. Routers are not where they don't have or provide a lot of the functionality to power the system as they are now.
Assuming that that the internet suppliers are not exactly adversarial to their customers, it seems like they would have a strong incentive to try to replicate this work, on their
Yes.
end. Often they're supplying the
it's like
router to the house. So it seems like they could actually, they could do the whole end-to-end system. They could, Verizon could do this. And
or
Comcast,
Comcast or
any of those,
AT&T.
right.
Yeah.
Right.
So we've interfaced with some. There's definitely been interest in the research from the actual providers, and we've also spoken to people like Cisco, because they make the hardware and so on. But so far, no one. I haven't quite made that connection. But I definitely think that you're right. If they were to do this, they'd be able to. The one thing, though, is there's quite a high barrier to creating these sort of systems. So I mentioned this was an HCI systems collaboration. It's not, like, without the expertise, it's really hard to actually create an interface like this that's powered by these measurements. And one of my future sort of goals is to try and make this easier so that more people can create systems like this and create something like a programmable router or something like that. Did you have?
Well, it's a solid question. What were some of the feedback you were getting from manufacturers, like Cisco and so forth, as far as integrating this into them?
They were very excited about it. It wasn't. I think Cisco does have some sort of cloud platform that they have. I don't know too much about it, but there's always been interest. It's just that I guess never made a full research connection.
As caps become more and more important, then I have shows.
Yeah.
I guess a privacy question. So you point out this tension between users. They always want more information. The other thing that you pointed out was, on one hand, they somehow wanted privacy from your system, yet they must realize that the whole internet is already tracking them. So I'm kind of wondering, when you put privacy as the forefront, do you think, was that actually a necessity, or that you thought in order for adoption? Or is it more that, this is, as a researcher or as an IRB thing, this was kind of like this, I don't want to say necessary evil, because it's not good to say privacy necessary evil, but something that you just had to do, but probably wasn't an important part of the system.
No, I think it is an important part of the system. So a lot of my previous research has shown that because of the nature of the home, privacy is very important, because in order to maintain the social relationships, you do need privacy. One of my previous systems was just showing bandwidth usage, so you could see devices and how much bandwidth they were using in real time. So you could tell, like, parents suddenly knew if their kids were doing homework or not, because they could see if they were watching YouTube because the bandwidth was going up. Another parent said something like, oh, I know my daughter is awake now because I can see her computer just came online. So although we were just showing bandwidth information, it was very minimal, this has serious impact on how people relate to each other in the home. So for me, privacy wasn't just something that was for IRB or whatever, it was an integral part of designing this to fit in a home environment.
But I guess the question was, there was privacy between what you collected,
Yes.
and also privacy in how you expose things to
That's
each
true.
other. And those seem very different, for example.
Yeah. Yeah, yes, so let me understand your question again. Can you?
You spent a lot of effort kind of minimizing what you
Yes,
collected.
yeah.
Alternatively, you could have been like every other internet service and collected all information.
Oh, right,
at a
and
time
show it
rate,
and then just hide it from us.
figure out how you want to expose this to users.
Okay. Yeah, I guess we could have said
Like every other internet company.
Yeah.
To pretend to know less than you do. when you
Yes.
sometimes,
I mean,
yeah.
people thought that anyway, so a lot of people were not sure if we were collecting more information than we said we were, right? And that was also hard for recruiting because people were like, well, you say you're collecting only this amount of information, but you're not. I think in that case, that would have been a good approach, but because of limitations of IRB, we couldn't just do that, right? So we had to limit what we were collecting to the bare minimum for powering the system. So in that case, yes, it was necessary to get the research done.
So presumably, so going off of what Adam said, presumably it would be easy for ISPs to implement something like this, maybe in a crude form. Do you have a theory for why they haven't done it?
I think, yeah, I think it's just like the barrier for doing this is really high. I mean, like I said, you need someone who's really an expert in network measurement, and then you need someone who's really an expert in interfaces to create something like this. So I think, first of all, just to try and create the system is really hard. So it might be that they just haven't reached that point yet. I think it would add value to their services, but as to why they haven't done it yet, I'm not sure.
But couldn't it be part of the pricing strategy to kind of like overdraft protection just for the convenience of our users?
Probably. I mean, we've thought about things like, because we did actually try, yeah, at one point I did try and commercialize some of the network awareness stuff. And so I had explored things like, well, how would you add this as a service for people? Would they be willing to pay, you know, an extra few dollars a month to get this extra sort of information about data usage or network performance and so on? So I definitely think there are business models behind it, but I can't speak to why an ISP hasn't done it. I think it's because creating a system like this is really hard. It's not something that just, you know, you have to have the right set of expertise to do it, and I think that's one barrier to it. Even for network awareness, I mean, most router interfaces are very rudimentary, and you would think that it would be fairly easy to improve them, but still, it's not really.
The people in California have Google, they don't have it either.
The people?
So Google acts as an ISP in California.
Yeah, like
Have
Google
they played
Fiber.
with it?
Do they have
So
some sort of,
they
they have an
obviously-
app.
But is it something
They have an app,
Yeah.
actually they have an app, and I'm currently speaking with them about creating a network awareness tool. Yeah.
So you said several times that it's very challenging to build a system like this. Can you say a little bit more about what those challenges are? And then you also said that you want to, by building this, help people build other systems like this. Are there like fundamental ideas that people can look at your system and then apply it to some completely different system, like a fundamental HCI or systems idea? There's two questions. Really.
Okay, so for the first thing, so one of the things I was saying people really wanted us to do was to show them Netflix versus Amazon, Netflix versus Hulu versus HBO. As it turns out, because we wanted to show people real-time information, a lot of the sort of work in networking that classifies network flows into things like this is a video, et cetera, is all done not in real time. So when we're trying to design the system and provide that information to people, we realized that this is actually a very hard problem to solve. To be able to categorize in real time network flows and associate them with this is a Netflix video and this is the session that people had watching that Netflix video is not very easy. So something as easy as showing people this is Netflix versus Hulu versus HBO is kind of hard to do in practice because of the things that you have to do in terms of analyzing the data to power that part of the interface. So I think one of the challenges is thinking about the data you have and trying to translate it into terms that the user wants, right? And you have to think about how you're going to translate that information to get it into that form. So every single piece of information that we had here, we had to think really carefully about how we would collect those measurements and how we would analyze those measurements and change it into a form that a user could understand. And then because of that, it means that many HCI people, for example, wouldn't be able to just jump on board and start creating the system without having a knowledge of how the measurements and the flows and everything work. In terms of whether this could be applied to other HCI problems, I definitely think so. So any time you have a system or an infrastructure that people don't understand a lot about, and you're thinking about how to make it visible, there's some probably general principles that can be abstracted from my work that could apply to making infrastructure visible to people. And that's one of my longer term goals. So I haven't actually done that yet, but I do want to kind of formalize or sort of make it more concrete the lessons I've learned from the systems I've developed so far.
So I have two questions. One about cultural specificity. specificity and then about unlimited usage.
Okay.
So I was curious whether you had any thoughts about the extent to which social norms and particular legal systems play into the behaviors of the various players in the system, both on the side of users and on the side of, for example, the ISPs. So in the US, for example, ISPs would have no incentive to help their users with this kind of a system because their goal is to have users go over their caps so they can exorbitantly jack up their rates. So to what extent do you think that there is a cultural difference in that? And then the second question is, there's been recent enforcement activity from the Federal Trade Commission in the U.S. around what it means to have unlimited access.
Okay.
And so I was curious if you had any data on the users who had unlimited access, what that functionally meant in terms of their access.
So the first question was on this cultural specific. Okay. So basically, yes, it definitely makes a difference. Actually, I think that people in South Africa also don't have any incentive to provide systems like this because similarly, if you go overboard, you will get charged a lot and they will make a lot of money. But I do think that just in general, internet usage is very different there because of cultural norms. For example, in South Africa, illicit downloading is way more popular because there's not like a RIA or enforcement. And so, for example, when I came to the States, I was surprised that, not everyone was just downloading music all the time and stuff, because that's how it is in South Africa, because we have a different norm. So yes, that definitely affects how people use the internet and how they would use a system like this. In terms of data on like the unlimited stuff, yes, we had users who basically told us, particularly in South Africa, the unlimited connections were way slower than the capped connections. And I experienced this myself when I went to South Africa. And the unlimited connections are not really unlimited. You have a certain amount of gigs that you can use during the day, and you actually have unlimited from midnight to 6 a.m. And then you also have a fair usage policy. So if they feel like you're using too much data, then they will actually shape your connection heavily. So unlimited doesn't really mean unlimited. I actually, when I was in South Africa recently, switched from an unlimited connection to a capped connection so I could have faster speeds.
Thanks. We've had so many questions.
Great.
We've gone a bit over time.
Okay.
So let's adjourn to informal discussion. Thank you.
Okay.